Let's talk about evaluating functions. Evaluating functions is something we've been doing a lot, and we got to make sure we just identify a couple things. First and foremost, the direction word evaluate. When we see the direction word evaluate, that means our final answer is going to be just one number. So anytime I evaluate a function, I should just have one number or one simplified expression, as you might see here in the next example. Another thing I want to talk about is just what are functions in general. We've been talking a little bit about functions. We talked about the domain and range and one-to-one and on-to. But what are functions and why do we use them? And so bear with me here, but I'm going to give us a cartoon animation or my best rendition of an artistic representation of what functions are. So given that we live in Pittsburgh, I'm going to use the function factory as my main focus point here to kind of give you an analogy for how functions actually work. So if you can envision, the old steel mills of Pittsburgh, maybe we got like a little bit of smoke coming out of them, all right, as they're working and they're pumping out all the different products and materials. So let's talk about that for a second. All right, here's our factory. But a factory, in order for it to work, has to have raw materials that come into it. All right? So if we're thinking about what comes into our function or into our factory, well, that's going to be our domain. So here we go. We got some sort of raw material coming into the factory, all right? And then the factory does all of its work on it, and then what comes out of that is the range. And realize that, whatever values come in, there's a good chance that different values are actually coming out after they do all this factory work or function work for that one. So that's actually what we're going to do over here on our examples. So on our examples, what we're going to see is that our factory, all right, is actually 2x squared minus 8. That's our factory, or that's our function. That's why it's labeled f of x. All right? F of x is the notation that represents a function. And so now the question's actually asking me to say, what is f of 6? So what we see is we replace the f of x with a 6. So anytime we see that notation, that's telling us, hey, we want to throw 6 into the factory. And then what ends up coming out of it, well, that's going to be where it's equal to, or the range in that case. So if 6 is the value I'm putting into the factory, I am simply going to do that. I'm going to put a 6 where the x was. Now note, I like to use parentheses for what I'm actually substituting into the factory or into the function. And so now that also keeps me straight that the 6 is the only thing being squared, not the 2. Make sure you follow orders of operations. So this is going to be 2 times 36 minus 8. 2 times 36 is 72 minus 8. And that's going to result in a 64. So when I substitute a 6 into the factory, a 64 is what actually comes out of that factory. But you can see that upon evaluating it there, we substituted 6 in, and we get the value 64. Now that's all good, but sometimes the questions can be a little bit more involved. Instead of just having one number, we could actually have an algebraic expression. Let's take a look at our second example. Our second example says evaluate it for 2y. So now you can see we're trying to figure out, all right, within the function, we're substituting 2y where the x values were. So what that's going to tell us is, again, 2, but instead of x, we're actually going to put 2y. And then everything else is squared minus 8. So everything in the actual function, 2x squared minus 8, I have 2. This part there represents the x, and that came from this value here. So this tells me what goes in. And then I still have my minus 8, like so. So once you actually get everything substituted in, now it's just down to some basic simplification. Again, only the things inside the parentheses are going to be squared. So this is going to result in 4y squared times 2. Just the 2 is multiplied by the 4, so it's going to be 8y squared minus 8. And note that these are not like terms, so therefore I cannot actually combine them. That's pretty much my final answer in simplified version. Now, if you're sitting at home, you might actually realize, well, there's an equivalent way I could write that. And something that is good that goes a little bit beyond level of where we're at right now is realizing, hey, these both have a common factor of 8. So I could actually rewrite this as 8 times y squared minus 1. Which later on, we're going to determine and figure out that actually that y squared minus 1 can be factored further. But for right now, that's just some preview of some future content. Our expected answer would be the 8y squared minus 8. But realize it's always good to look at answers in their multiple form because sometimes the other forms might be helpful for us down the future.